Today we're looking at stem and leaf plots and dot plots. Now, stem and leaf plots basically give us all the advantages of a list, but also all the advantages of a histogram. So they're quite clever. So the first thing I've written here, like a histogram, you can see the shape of the data. And like a list, you can see the detail of each score. Now, the easiest way to understand this is for me to show you what I mean in an example. So, example, we measure the heights of all of the students in our class. Let's just imagine that I've lined you up at the board and we've measured everyone's height in centimetres. Now, I could just write the list down like this, and that has all the detail that I need, showing all of the heights that I've found. The problem is when you just scan that with your eye, it's really hard to see what's common or what's normal. You've sort of got to pick your way through the data. And all the detail is there, but you don't sort of get a snapshot. So we looked last lesson at how we can make this into a histogram. Now the advantage of the histogram is that we've got the frequency down the side here, which normally I would label 1, 2, 3, I just haven't finished it, 4, 5, 6, 7. So I can clearly see here that this is the tallest column. So obviously most of the people in the class are 160 something or 170 something centimetres according to this data. And I can see that this is the least common sort of height to be, these tall people, or perhaps these shorter people, and I can at a glance really quickly and easily tell what's a kind of normal height for people in the class. The disadvantage of this though is I've lost the detail. These two people that are 180 something, were they 180 exactly? Were they 189? I can't tell, and so my snapshot is great, but my detail is hopeless. Well, a stem and leaf plot looks like this. It basically takes the histogram and turns it around 90 degrees and puts it on the side. So it says, all right, if you want to group your data into 10 centimetre intervals, let's do that. So these people, these three, 151, 156, 157, they're all 150 something, right? Now see how those numbers all have the 1 and 5 as the first two digits. So we call that the stem part because that's the part that these three scores have in common, the 1-5 bit. And we say, let's put all the 1-5 somethings together. So we've got our 151, 156, 157 listed there in a row. Now you don't need to put a comma in between them to separate the scores because the whole idea of these is that the leaf is just one digit in size. So you build your stem part and your leaf part on purpose so the leaf is just one digit. That way you can just place them beside each other. Now when you place them, it makes sense, just like with a dot plot, which we'll see in a minute, to put the numbers nicely spaced. Now if you're working on grid paper, put one number in each little square of your grid book, and that helps you get the spacing right. Now if you space them that way, then the advantage is that just like you can see which is the most common thing to happen on the histogram, you can see which is the longest list on the stem and leaf plot. And so really your eye is going to see that basic shape, isn't it? And you can sort of tell, all right, this is the most common things. There's two people who are 180 something, there's three people who are 150 something. But then if you want that detail, well, how tall were they? 180 what? Oh, they were both 182. You've got the advantage of the list and the snapshot view of the histogram. Now, you have to have a key on your stem and leaf plot, and the key looks like this. You will have a stem and then a bit of a line, because you'll notice that the stem and the leaves here are divided like by a big vertical line. So you just put a vertical line and then you put another number. And you say, all right, if there's 1-6 and then a line 4, that would mean 164 centimetres. That way you can look at all of this data and go, all right, so this 1-8 line 2, that means 182 centimetres. And so now you can interpret it. So now let's have a go at taking a list of numbers and making a stem and leaf plot out of them. Now, who knows what these numbers represent? It could be anything from some survey results. But if we want to group the data, first we've got to decide what the group's going to be. Now, we need the leaf part just to be one digit. So it makes sense to have the teens together, the 20-somethings together, the 30-somethings and the 40-somethings. That looks like as much as I'll need. So first scan your data and just see how big is the smallest and the biggest stem part. So I can see I've got teens, I've got 20s, I've got 30s, and I've got 40s. Then I make my line down here. I can do my key already if I like, and say, look, 1 something 7, that's going to mean 17. All right, now it's important that you put the data in order. So you go from smallest to biggest. So I'll generally just cross numbers off as I use them. So I've got 12, 17, and 18. Now notice I don't have to write the 1 each time because each of them has a 1, and then you just write their other number. All right, the 20s, we've got 23 and 28. So we write the 23 first, then the 28, and notice how I'm keeping my numbers under each other. Then the 30s, we've got 30, 32, and 35. And 40s, we've got 45, and that's it. So we can see the shape of the data, and we can also see the individual scores. And one last thing that you can do with stem and leaf plots, you can make what's called a back-to-back stem and leaf plot. Now you might want to do this if you're comparing 2 different populations. And remember, a population doesn't have to be everyone in the world, it's just a group that you're interested in. So we looked at an example with heights of everyone in our class just before, and I made up the data. I just pretended that I'd measured you because I don't have you all in front of me right now. But if I was to say break that data up into the boys in the class on one side and the girls in the class on the other, then I can separate the data like this. I can keep the same stem part, but then I can put the leaves going out one way and out the other way for my 2 different groups. So you'll notice that for the girls it looks like a normal stem and leaf plot. For the boys, the numbers would actually increase as they go out this way. So if I had, say, several numbers to put, let's say I have somebody taller here, it was a 56, it'd have to come out this way. So the numbers get bigger as they get further out from the stem. Now this shows you a few things. You can see in a snapshot just the shape of the data, what's common for the girls in the class there or for the boys. You can also see straight away that there's only 4 boys in this data set, so straight away you've got that information at a glance. And you can see that on average the boys are a little bit taller because the tallest couple of people were boys. So you can look at data that way. You might also have compared the heights of everybody in our class with the heights of everybody in another Year 10 class. And that way you could compare and at a glance really easily see who fits where. Now a dot plot is just like a column graph, except instead of drawing big blocky sort of columns, we just draw a column or a line of dots. Now there's 2 ways that you can do it. The simplest ones are like this, and each dot just represents a single score. So if I did a survey of you guys and I said, how many brothers and sisters do you have? I might take a little bit of a tally. I'd start off by making myself a frequency table, and I'd say the number of siblings that you might have might be any of these numbers. And then if I took a bit of a tally and went, all right, I've got 3 people who had no siblings, so their only child. 4 people had 1. 6 people had 2, etc., etc. Then I could put these results into a table like that, or I could list them like this in a dot plot. Now you don't necessarily need a scale on the side of a dot plot because you can just count the dots. So if you're interested how many people had 2 brothers and sisters, you can just go 1, 2, 3, 4, 5, 6 and count them. Now the problem would be, what if you've got heaps of dots? What about if I ask this question to everybody in New South Wales and now we've got a crazy number of dots to count? It wouldn't make any sense. So the more complicated dot plots actually use a bit of a key, and you might have something like 1 dot equals 1,000 people. And so if there's 3 dots and you can see this key over on the side, you would say, oh, that's 3,000 people answered that way. So you can do them with a key. I think all the questions in your exercise 5C are just the simple ones like this, but it's good to know how you can use them in case you've got a lot more data points.